Okay, so let's try 5, 4, and 1. Let's just go over those real quick because I'm going to make sure you guys are getting these concepts. So, number 5, so 1 is 4x squared, no, 4x cubed, sorry, times 2xy squared times 3x cubed y squared. This was what we did in the distribution problem as we were reviewing applies to this, right? It's the same idea, it's just we don't have to distribute, it's just all already multiplied together. So what numbers can I multiply together here? Or what values can I multiply together?
4, 2, and 3.
4, 2, and 3 is first, so 4 times 2 is 8, 8 times 3 is 24, so our number in the front is going to be 24, and then all the x terms I can actually simplify, right? So I've got x to the third power, x to the first power, yep.
I thought you couldn't multiply 4, 2, and 3 because 4 doesn't have a y.
That's if they're added. That's the difference, right? When you do like terms, if it's this, let's see, x y squared plus 3x cubed y squared. We can't add any of those. We can't make that any simpler because none of them have the exact same variables. So like terms are important whenever you've got addition and subtraction in between them, right? When you're multiplying, you just multiply everything that's got the same base and everything that's a number. So 4 times 2 is 8 times 3 is 24. We can multiply our x's together. X to the third times x to the first times x cubed is going to be x to the 3 plus 1 plus 3. I'm just adding together all of their exponents.
7.
Huh?
7.
7, that's right. So 24x to the 7th. And then finally with y, we've got a y squared and another y squared. So that's going to be y to the 2 plus 2, which is y to the 4th. So this should have been your final answer. All right. What was the other one that you said? 5, 4, and 2? Is that right? 4 was the next one. So again, this was one similar to what we did before, but with this one, it's actually a little simpler than the one that I did on the board because we can combine like terms. So we're not going to have to move the fraction over and get a common denominator and all that sort of stuff like we did before. These are like terms. So with your question, Alexa, with us not being able to multiply those together, you were getting confused about like terms. This, we've got the addition sign, so we can only combine those if they have the same variable, and they do. They each just have an r, right? So the way that I would combine those together is I would say 14 fifths plus 1 fifth is what? 15 fifths r, right? I combine the numbers together because they're like terms. When they're like terms, you add or subtract their coefficients. Remember, coefficients are the numbers that are in front of our terms. It's the 3, the 2, and the 4 right here. In this case, it's the 14 fifths and the 1 fifth. Those are the coefficients, all right? And 15 fifths, of course, can be simplified to be just 3, right? 3r. And so now I want to divide both sides by 3, right? So r is going to be equal to 7 halves divided by 3. How do I divide 7 halves by 3?
You're going to flip it and multiply?
I can flip and multiply, right? Because remember, this 3 is just 3, it's a fraction too. It's 3 over 1. And so if I flip it and multiply that together, that means that r is going to be equal to 7 halves times, times 1/3. And so r equals 7/6. That would be the answer for that one. All right, and then finally number 5, it says minus 2x plus x equals 4x minus 10. Again, we're going to combine like terms. Yes?
I just didn't understand because it had 3 x's.
Had 3 x's, right? And so whenever we're solving for x, our first step, I mentioned this in one of the problems, but we didn't actually have that in the problem, so we didn't walk through it. But I said your first step, if you've got variables on both sides of your equation, get all the variables on one side, okay? So we're going to move this 4x over. So we've actually got negative 2x plus x minus 4x equals negative 10. All I did was subtract the 4x from both sides, all right? And so that's what I get when I do that.
So why wouldn't you subtract it from negative 2?
I am. I'm about to do that. I just haven't done it. I'm just writing it out so that we see that we because these are all like terms, because they all have an x, we can now add and subtract these terms, okay? So we say -2 plus 1 is what? You can always do it until I put you on the spot, right? -2 plus 1 is -1, right? And then -1 minus 4, which is the next coefficient, is -5. Okay, so this answer here is -5x equals -10. Did I lose anybody when I did that? All right, I see some people writing on their quizzes. You're not correcting them, are you? Okay.
No,
all
I was
right.
just like writing down the solution. I wasn't like marking off my X.
Well, I just don't want to get confused when I'm grading it and say, oh, he got it right. Because here's the solution out beside it, right? Or take this down on other pieces of paper instead of writing it on your quiz, all right? Did I lose anybody here? So now what am I going to do? I need to get the x by itself. I've got x multiplied by a -5, so what do I need to do? Divide by a -5. Right? Those cancel out now, so I've got x equals -10 divided by -5 is 2. So that would be my final answer for that one. All right, so let me take those up from you guys. Thank you very much. Sorry. So I think that there is potentially some confusion still with the with like terms, when you can combine them together and when you can't. And so that is a really important algebraic concept that I want to make sure that you guys understand. I don't want you to get confused about that. But the basic idea is that if you're adding and subtracting, you can only add and subtract terms if they have the same variables, right? Those are what we call like terms. Like terms matter when you're adding and subtracting. When you're multiplying, it doesn't matter. Like if I had 4x times 2x squared times 3y, they're multiplied together, so they don't have to have the same variables. I can multiply all of the numbers together. 4 times 2 is 8, times 3 is 24. If they have the same bases, I can simplify, so x times x squared is x cubed. Can't do anything to y, so I would just rewrite that like that. Right? I'm not concerned about them being like terms. I'm only concerned about them having the same variables if we're adding and subtracting. Yes?
Could you do 8x to the third power times y?
8x to the third power times y?
Because as if you were like multiplying the 4 and the 2, and then that became part of it, and you left the 3y by itself and just added it to it. I'm just curious.
Well, you could do it in parts. You could do this. You could say, okay, we're just gonna, because it's just like if you multiplied this, 2 times 3 times 4. All right? I can multiply this together first and say that this is 6 times 4, and then multiply the 6 and the 4 and say the final answer is 24. Okay? I can do the same thing here. I could say 4x times 2x squared is going to be 8x cubed.
That's
Okay.
what I'm curious about. If you can leave 8x to the third power times
3y.
I'm just curious.
But now when I do that, I need to recognize there's still multiplication I could do, right? I wouldn't leave this problem like that,
Okay.
right? I would do the final multiplication. So I say 8 times 3 is 24,
Alright.
and then I would write it like that. So anywhere where your little dots are, because when you're dealing with variables, just putting the numbers beside one another means multiplication. You remove the dots and you just put the variables beside one another. Yeah.
Can I grab tissue?
Yes. Any other questions about that? Yes.
Are you gonna pass?
Yeah, sure. All right, so I'm going to go over the end of chapter 28, or lesson 28, one more time, the second half of that, where we're doing functional notation. And because like I said, that was very rushed last time. So we had two problems in the homework that used functional notation, and I think if we kind of walk through these, you'll see just how simple this is. It really is a simple concept. And the other one was g of x equals x to the x squared minus 3. And so they ask us to find f of negative 1. What does that equal to? And g of 2. What is that equal to? All right. So when we're looking at something like this, we need to recognize, this is what, like I said, what we call functional notation. The way that we read this is f of x. All right, that's how we read that right there. So if I say f of x, that's what I'm talking about. And what it means is that whatever this is equal to, this expression over here is a function of the variable x. It means that it's an expression that has some variable x in it, is really all it means, right? It's dependent. X is the independent variable, and then what we get for the whole function is dependent upon the value of x. And so when you see this right here, and then they tell you to find f of negative 1, negative 1 replaces what from the original one? What did we have here before in the original expression? We had an x, right? Does everybody see that? Negative 1 replaced the x right here, okay? And so all this means that we do is we take everywhere that there's an x then on this side, we replace that with negative 1. So all I do is if I have an x, I put negative 1 in there. And then I simplify that, and that will tell me what f of negative 1 is. Okay? And so what is negative 1 squared? Since the whole thing's in parentheses, what would the value of negative 1 squared be?
Negative 1 times negative 1.
It'd be negative 1 times negative 1, which is just 1, right? So it's 1 minus 3. And so what's 1 minus 3?
Negative 2.
Negative 2. Thank you, Dan. Negative 2. That's our answer. We just took, because we were finding f of negative 1, everywhere we saw an x, we replaced that x with negative 1, which is what we did right here. Same thing applies over here. It was an x up here. We need to replace the x with the 2. All right, so everywhere we see x, we're going to plug a 2 in it. So this x becomes 2. This x right here becomes a 2. And that's the problem that we're actually trying to solve. Isn't that really simple? Like once you see what you're supposed to do, that really is a simple concept. You're just taking the x and replacing it with whatever number is in the parentheses here. Okay? So when I simplify this, 2 times 2 squared is 4 minus 3. So we always do our powers first. We have to make sure we remember our order of operations. So we do powers first. Then we do anything that we can simplify in the parentheses, we do that. 4 minus 3 is 1, so we have 2 times 1. And so our final answer is 2 for this one. I didn't set a good example for you guys. Let me box off my negative 2 there. Does that make sense? Now, what I would recommend doing, and I didn't follow this practice here, so let me show you how I would recommend. I would recommend always taking it didn't matter here, and so that's why I didn't do it. But sometimes it does matter. So I would kind of recommend always, wherever you see the x, I would always put the number 2 initially in parentheses. I would write it like that. And the only reason why is because if there's a negative sign in here like there was right here, putting in parentheses makes it clear to us that we're squaring the whole thing, right? In this case, it would have mattered that it was in parentheses. Because remember, negative 1 squared is not the same as parentheses negative 1 squared. What's this? That's negative 1, right? Because the square only applies to what's directly to the left of it. So this is the same as negative 1 times 1, which is negative 1. This is the same as negative 1 times negative 1, which is positive 1. All right. So I recommend doing this because we didn't have a negative sign here. I sort of skipped that step. It's good practice to always put the parentheses in there, just so you'll take care of any negative signs that may be in your problem. Okay? So I'm hoping after doing that slowly that everybody's like, oh, that's super simple. That's really easy. So let's say I gave you this, and I said h of x equals x squared minus 2x plus 3. And I said I want you to find h of negative 2. What am I going to do?
Replace all the x's with -2.
Replace all the x's with negative 2. Like I said, use parentheses to make sure you don't make a mistake with your sign. That's my first step. Everywhere there's an x, I put parentheses -2 there instead. You just got half credit for your problem if you do that step right there. Because you showed me that you understand all that I'm doing with this problem is replacing x with -2. And now it's just a matter of actually doing the calculations for each of the terms. So -2 squared is what? If it's in parentheses? Huh?
Positive 4.
Positive 4, good. And then that's -2 times -2. What's that going to be? Yep.
-4.
We have a
Oh, wait.
negative
Oh.
times a
I
negative,
see that.
so it's going to be positive. Do you see that?
Mhm.
So it's going to be a +4. And then finally we've got a +3 hanging out on the end. So we just say 4 plus 4 is 8 plus 3 is 11. That's our answer for that one. And at this point, that's as complicated as it gets. So, any questions about that? All right, cool. Let's go to lesson 29, which apparently I've already taught you guys, except for Alexa, who wasn't here. Sorry about that, Alexa. I hope you'll be able to sleep tonight. I'm sure she wasn't able to last night, but now she'll be able to sleep. So the first thing that we want to learn is how to deal with negative exponents. And we need to understand this, that 1 over x to the n power is equal to x to the negative n power. And so what that means is that if you have a value raised to a particular exponent, let's say we've got x cubed. Remember, every number you can think of as being over a fraction. I mean, being a fraction because you can put that number over 1, right? And so the way it works with exponents is if I move whatever term's raised to some exponent to the other side of the fraction, you have to flip the sign. So x cubed over 1 is the same as 1 over x to the negative third power. When I move it to the other side of the fraction, I have to change the sign on it. If I had 2 over y to the negative 3, I did 3 last time. Let's do negative 4. 2 over y to the negative 4, and I want to move that y to the top. I want to get rid of the negative exponent. I just move it to the top of my fraction, and so that's the same as 2y to the 4th. So when you move it to the other side of the fraction, if it's in the numerator, if you move it to the denominator, or you do the reverse, if it's in the denominator, you move it to the numerator, you just have to flip the sign on the power. Okay, does that make sense? So this is our basic rule to remember that. But I want to make sure that you guys are clear. I could say this. I could say 1 over x to the negative n equals x to the n. That's also true. Right? Because I'm moving the x to some power to the other side of the fraction, and so the sign just flips on it when I do that. Now this doesn't have to be a variable here. This is anything that's raised to a power. So it could be a number raised to a power. So 3 to the negative 2. I don't know how to do that, right? I don't know how to raise something to a negative power. I only know how to raise things to a positive power. So what I do is I say that this is equal to, since I can think of this as a fraction where the whole thing's over 1, let's move it to the other part of the fraction. Let's move what's in the numerator back up. slow down a little bit. Let's move what's in the numerator to the denominator, all right? So we're gonna move that 3 down, and when we do, we change the sign on the exponent. So it becomes 1 over 3 squared. And now we know how to calculate that. What's that equal to? 1 over 9, all right? That would be our answer. Now, you guys have, yes?
Why would you take away the negative?
Because if I move it to the other side of the fraction, if it's on one side, if it's in the denominator and I move it to the numerator, I have to flip the sign. So whether the sign's negative or positive, when I move it to the other side, I have to flip the sign. And that's true if it's on the top or the bottom. Let me make sure that you guys get. I could rewrite this as this too. I could say x to the n equals 1 over x to the negative n. So anywhere, if I move it to the other side of the fraction, then I have to change the sign. Okay? If it was positive before, I have to make it negative. If it was negative before, I have to make it positive. So because we took what was in the numerator and we moved it to the denominator, I had to change the sign on the exponent. Make sense? Now you guys have calculators, right? So even though we don't know how to do 3 to the negative 2, your calculator does. So I can check my answer with problems like this, right? I'm going to expect you to be able to give me the fraction, but if you do 1/9, what is that? What does your fraction say 1 divided by 9 is? And what does your calculator say 1 divided by 9 is?
Error.
1 divided by 9? It's got to be some decimal.
It's like 0.
A lot of ones.
What is it?
Point a lot of ones.
0.1111. So 1 repeating. All right. So now type this in your calculator. Do 3 to the power, and depending on your calculator, you may have a key that looks like this, y to the x. That might be how yours looks. Some of your calculators may have the caret key, which looks like this. That'll do the same thing. Does anybody have anything else? Are you having trouble?
X with a little square.
X with a little square, yeah, okay, so you may have 3 and X with a little box right there, okay? And so if you type in 3, and then next you press your negative key, a lot of calculators nowadays will have something that looks like that.
I have a button that's for negative ones. Like you can press it and it will do a negative exponent.
Oh, okay, yeah, some calculators may have that. Let's see, so you also have what she mentioned. You have that one as well. How do you do a minus? There's your parentheses. I just want to make sure what you can't hit right here is you can't hit just your minus key. You're looking for the key that actually makes a number negative.
It just ended up giving me an error.
All right, we'll see that in a second. And so I'm going to do negative and then 2. So I should be able to punch that in my calculator and get that 0.1111. This is why you should bring your calculators to class so you can figure out how to do this stuff on your calculator. So this one may be weird and nothing like yours, right? So 3, let's see, let me clear. I don't even know how to use this calculator. There's clear, thank you. 3 raised to the, where did you see that?
Oh, I just hit the yx like you.
Oh, there it is, yep. 3 y to the x
No.
minus, so this. Actually, you know the way this one works is you got to hit the 2. Let me clear that again. On this one you have to do this and hit the 9, hit the 2 and then do negative.
Oh, I'm subtracting.
Yeah, you can't hit the minus, you got to hit this key.
Oh, mine hit the minus.
Right.
That makes sense.
This is an old calculator. Most calculators have the parentheses negative. This one has like a plus. That particular one. Instead of this right here, it has a plus minus key.
Okay.
All right, so some of you may have a key like that. But this is important that you know how to do this because this is part of the way that you can verify that you got the right answer, right? You can use your calculators to help you figure that out. You still need to know how to do the process. You'd never get 1/9 if you didn't know how the process worked, but this is a way for you to check your work. Okay, yes?
I actually got 1/9 on mine because you can do fractions.
Because you got fractions on yours. So yeah, some of you have fancy calculators and it'll do the fractions for you, which is cool as well. But here's the problem. If you don't learn how to do the stuff and you just rely on your calculator, at some point you're going to have to do a problem and you're going to have to know how to do it, right? And so you're not going to be able to do the problem the SAT and the ACT has portions of the test that are no calculator portions, right? So you're going to have to understand how this stuff works in order to get through the no calculator portion. So make sure you learn the concepts and use your calculator as just a way to check your work and make sure you got the right answer. Does that make sense? All right. I'm not to be mean, but I'm going to grab my calculators while I'm thinking about it, so you guys don't walk off with the calculators. All right. And if we need them again, I'll give it back to you. It goes the other way. Thanks, sir. Appreciate it. But yes, please bring your calculators to class. Try to remember those because that's what you're going to be using on when you take a test at home. And I want to make sure you know how to use your calculator. Okay. So what about when we have when we're multiplying exponents together? We've already covered this. X to the 3 times x to the 4th is what?
X7.
X to the 7th, right? We just add those together. We add the exponents together. So this is x to the 7th power. Well, what if we have negative exponents now? What if I have x to the 3rd power times x to the negative 2?
It'd be x to the 1.
X to the 1, right? We're doing the same thing. We're still saying this is the same as x to the 3rd power plus negative 2, which is the same as x to the 3 minus 2, which is x to the 1. We would never write it like that. We would just write x, right? Because the 1 power is always understood. Okay? Any questions about that? So the rules don't change as far as multiplication goes. They still work the same way if you have negative exponents as well. You're just going to have to sometimes be adding negative numbers when you're doing that. So here's the problem. Alexa, do you know what x to the 0 power is? You don't? No, you don't remember? What's anything to the 0 power?
1.
What is it, Cohen?
1.
It is 1. Anything to the 0 power is 1. You guys, the whole back row was in on that, so I'm going to put Joan on the board as well. Right? Anything to the 0 power. If I put 5x squared minus 3x plus 2ac and I raise it to the 0 power, that whole thing becomes 1. Right? Doesn't matter what it is. If you raise it to the 0 power, the answer is always 1. All right? Yes?
If you had a negative, would that change it?
If I had like a negative inside here,
Or just like a negative on like a problem where you would put it to the 0 power, would it change it?
so like a negative 2 to the 0 power,
Uh-huh.
or yeah, that would still be 1. Or if I had 2 to the negative 3 raised to the 0 power, that would be 1. Anything to the 0 power, doesn't matter what it is. If I put Alexa to the 0 power, it would be 1. All right?
What if it was raised to like a negative 0? Is that a thing? Would they
Well, negative 0 is not really a thing, right? So we think of negative number as being numbers that are less than 0, and then numbers that are positive are the numbers that are bigger than 0. There's really no idea of no concept of a negative 0, so you would never see that. But if somebody mistakenly put that on there, I would say still it's 1. All right? Yes. Did I see another question? Another hand? All right. All right. Everybody good with these rules? So the 0 one's just a weird one that you just have to remember, right? There's no good way for me to explain that. It's like if I don't have, if I know that x to the 1 means I have 1x, so that equals x, that makes sense. And x to the 2 means I have 2 x's. So why would x to the 0 be 1? It's just a rule. All right, so it's just a rule that you have to memorize. You just have to know that. All right. Let's move on to the next section. And yes, yeah, go for it. So lesson 30, algebraic phrases and decimal parts of numbers. All right. So the decimal parts of numbers is going to be really easy if we understood the fractional parts. It works exactly the same way. It's just that now we have a decimal instead of a fraction. And that shouldn't be a big surprise to us because you can easily convert fractions to decimals, right? We know how to do that. You can easily convert decimals to fractions. I don't know if you remember that you know how to do that, but you do. Do you guys know how to convert decimals to fractions? Sort of. So like if you say 0.2, what you have to remember is that is the tenths place.
You
All right?
divide it by
So
10.
0.2 is the same as 2 over 10. Right? If you had 0.34, this one goes all the way to the hundredths place, so you would write that as 34 over 100 and simplify it. So that's how you convert from decimals to fractions. Yes?
If you had like a 0 in front of like the 3.
The 3? Okay,
Maybe
so it was,
1,000?
if it was 0.034, yep, it goes all the way to the thousandth place, so it would be 34 over 1,000. All right? That's not in this chapter, but you guys have learned that previously, but it may have been a while since you've seen it, so I just wanted to make sure you remembered that decimals and fractions are really the same way. It's just different ways to represent the same number, okay? So when we talk about doing fractional parts versus decimal parts, the equation is going to be the same. We're going to have that whole F times W equals the part, but instead of F, we're going to have the decimal, right? The decimal part times the W equals the parts. Same idea. But before I talk about that, let's talk about algebraic phrases. And they just want to make sure that if I make a statement, that you know how to build an equation based on that statement. Or build an algebraic expression based on that statement. So for example, the sum of a number and 7. So anytime they give you something like that and they say a number, then it's always a good idea to just use the capital letter N to represent some random number, right? But you don't have to. Any variable would suffice. We use X commonly as a variable, so you could use an X in there if you wanted to. But when they give you a statement and it says the sum of a number and 7, you need to think of this. A number plus 7, because we said sum, right? And when we say sum, S-U-M, the sum of a number and 7, we mean we're adding 7 to a number, okay? If I say 7 less than a number, how do you think I would write that? 7 less than a number.
And minus 7.
And minus 7, right? I'm doing subtraction in that case. So 7 less than a number would be take that number and subtract 7 from it, right? If you ever get confused with these things, plug in a real value. If I said 7 less than 8, you would say that's what? What would you say, Liam? 7 less than 8 is?
Probably -1, right?
No, 7 less than 8. What I hope you would say is you would start with 8 and you go 7 less than that, right? So positive 1. So it's 7 less than 8 is 8 minus 7. 7 less than any number is that number minus 7, n minus 7. Okay? The opposite of a number, when I say the opposite of number, the opposite of 2 is what?
-2.
Negative 2. So if I say the opposite of a number, what is that? If I'm just using some variable for a number, it would be negative n, right? So the opposite of a number would be negative n. What if I said the opposite of a number decreased by 5? That would be the opposite of a number is negative n minus 5. I'm decreasing that number by 5. Okay? So there's all sorts of expressions they have here. What about the sum of the opposite of a number and negative 5? Woo! That's putting a lot together. All right, so let's think about that. The sum, I'm going to write that down. The sum of the opposite of a number. I'm going to use that for my represent a number. The sum of the opposite of a number decreased by 5. By negative. Oh, no, decreased by. Did it say decreased by 5? The sum. No, they said the sum of an opposite number. Sorry, and negative 5. Yeah, that doesn't make sense. The sum of an opposite number. The sum of the opposite of a number and negative 5. There we go. Almost there. Sorry, guys. I'll be there in a second. So take it in pieces. The opposite of a number, we said, is negative 5, negative n, right? And if we're taking the sum of that number and negative 5, what does that mean?
Adding.
We're adding, so we're going to add to it a negative 5. But that's not how we would write that, right? We'd get rid of the parentheses and we'd write that as negative n minus 5. Okay? So this would be the equation for the sum of the opposite of a number and negative 5. It actually ended up being the same as what we had last time, which was the opposite of a number decreased by 5. All right? let's see if somebody can give me this. Don't look at your book, and let's see if somebody can tell me what this would be. What would be the sum of twice a number and negative 5? How would I say twice a number?
To the second power?
No. How would I say twice a
I
number?
was gonna say n squared.
No. That would be, is that twice a number?
Times 2.
Yeah.
It would be times 2. Right? So twice a number. Is 4 squared twice 4? 4 squared is 4 times 4. So it depends on what you make of the word twice. In their case, in the math book, if they say twice a number, they're wanting you to multiply it by 2. All right? If they say 3 times a number, they're not wanting you to raise it to that power. They're wanting you to take the number and multiply it by 3. Okay? Does that make sense? So twice a number would be 2n, and they said the sum of twice a number and negative 5. So what else would I have to do? The sum of twice a number and negative 5. Yep.
Plus negative 5.
Plus negative 5, which is just minus 5. Right? So that's the sum of twice a number and negative 5. Whew, here's a long one. Okay? 6 times the sum of twice the opposite of a number and negative 8. I don't even know what you just said. Like the scene in Napoleon Dynamite. You guys ever seen Napoleon Dynamite? Yeah? When Napoleon's asking them if the chickens have large talons. And the guy goes, son, I don't understand a word you just said. So let's read that again. 6 times, I want to write it down. 6 times the sum of twice the opposite of a number of a number and negative 8. All right, let's take it in pieces. 6 times the sum of twice the opposite of a number and negative 8. Where in the world are we going to start on this one? There's a lot going on, huh?
I'd say put the 6 in the parentheses, add a plus sign, then twice of opposite.
Okay, so we know we're doing 6 times the whole thing. So I like that.
No, I was saying 6 around.
Oh, you're
the
saying put 6 in parentheses. Like that?
And then
Okay, that's cool. That'll work too.
it
Alright,
says the opposite, twice of the opposite. So I'm thinking 2 negatives.
So
and then-
twice means when we said twice a number, we had that, right?
Okay.
But if we're doing twice the opposite of a number, do you guys see that it would be that?
Yes.
All right. So 2n. We are going to need parentheses here because we're multiplying the 6 times the whole sum. All right. So we've got some sum in here. We know we're adding something together. You guys see that?
Yeah.
So 6 times the sum of twice the opposite of a number. There's our negative 2n. All right. And what are we summing together? Twice the opposite of a number and
Negative 8.
negative 8. All right. So if I simplify this, it's actually going to be 6 times negative 2n minus 8. You guys see that? That would be our expression that represents that. Did I lose anybody in that? Because you're going to start having problems like this where it's not in this chapter, but you're going to have problems in future chapters where you've got to make sense of these words that they put down. You got to make sure you can take those words and convert them into an expression like this. Yes?
Would you then simplify that?
So you could. What would that simplify to be?
Would be 6 times 2n.
6 times negative 2n, which would be
2n, right,
which would be negative what?
negative 12.
Negative 12n, right? 6 times negative 8 is
48.
negative 48,
Well, yeah.
right? So we could simplify it to be that, right? And both of those would work. Typically when you're given something like this, you'll end up having to get a numeric answer. And so you're going to plug something in for the n and then get whatever the final numerical answer would be. And so both of these equations would give you the correct numerical answer once you did that. If I just asked you to show me this written out, I would accept either one of these, right? You need to get to this point. I especially want to make sure you can get to that. But then if you simplify it further and do that, that would be correct as well. Okay? All right. So let's move on from there. You guys will, I don't even know if they'll give you any practice problems with that. Oh, they do. Cool. So you got some practice problems where you can work on that. Let's talk about decimal parts of a number. Because like I said, decimal parts, oh, we got to go, don't we? Okay, decimal parts of a number, you'll have some homework on that. They work exactly the same way. Remember, instead of fraction times W equals P, it's the decimal part times W equals P. Okay? So you'll just plug in your decimal here, you'll plug in your whole number here, and your part number there. We do it at 11:10, right?
Yes.
Okay, all right. You guys have a good day, and just reach out if you have any questions about that, all right? I think you'll do fine on the decimal stuff. So just 2 chapters this week, right? Everybody clear on that? Just lesson 29 and 30 is all we got to do. The practice and the odd problem set. Or is that the verse? Is it the reverse? You guys know what I mean. Lesson 29 and 30. Have a good one.
Thank you.
Yep.